This story already began a decade before now and was nearly finished. But real difficulties on making a VTOL jet will just appear shortly before the finish line. And after 10 years of experience with the SUXR, it was time to take a completely new attempt. This video is sponsored by PCBWay. More on this later. The SUXR was made of super lightweight composites. Now, 10 years later, there is a new technique available, and this is super lightweight 3D printing. Printing the test part for our new gear on the JRM with here are they. Front fuselage part from the Bamboo Lab, printed with color fab. Looks amazing, these details. The amount of work for making a composite airplane is enormous. You have to apply different layers of fiberglass, carbon fiber and Kevlar. In between there is a honeycomb to build a sandwich construction, and after this it has to put in vacuum and cured in an oven. And all these steps has to be repeated for every single part. Building the SUXR VTOL jet took the same time, 6 months, like the whole construction, designing and building process. The SUXR was a technology demonstrator to show off if the used components are capable to make a successful transition. And this works. And that's the beginning from the JRM1 project. This jet should be improved in every single aspect. So the SUXR was just the beginning. Technical details like the main lift fan cover or the droop nose, even the wing covers, will transfer to the JRM. Gained a lot of improvement to see if 100% longer hover time will be possible, and this means minimum 5-minute hover time. Beside efficiency, the key point on VTOL is the 100% accurate working of the lift fans and also the lift fan doors. So a first wing was printed with the Bamboo Lab. The lightweight PLR print profiles you will find on my Patreon page. Link is below in the video description. And they open and close safely in every thinkable possible situation. So they got an approval and we could go on with the whole jet construction. After printing the JRM1 in a smaller scale, a lot of surface failures became obvious, which were not visible in the CAD. Also, the main ducting was improved for maximum efficiency. Functions were checked. And finally, the first JRM1 prototype was printed. And then it was time for the first engine installation. Even if the EDF swing works nicely, this first design has too much flaws, especially the aerodynamic and the weight goal was not possible to keep, so we had to start completely new. While we are on our first version of the JRM1 mostly focused on the outer design.
Have you ever had the need for a fast response solution for prototyping or small batch production run on a design or mechanical project? Well, PCBWay may be the answer for you. PCBWay offer a quick turnaround and superior quality on a range of rigid and flexible PCBs with a focus on prototype runs and low volume projects. But that's not all. Despite the name PCBWay, the company also offers CNC machining and milling services. They also provide 3D printing and a wide range of formats and finishes. Additionally, sheet metal fabrication with laser cutting, bending and post-processing can also be ordered, and should your project require injection molded components, PCBWay offer rapid tooling and multi-cavity tools. With a superb online ordering system, simple drag and drop file uploads and real-time fabrication tracking, make PCBWay your go-to on your next project. PCBWay.com.
This time we take an absolutely new approach. We're focusing on lightweight construction and also optimizing the inner ducting.
Having decided that our JRM jet was too large, Renee and I went through the process of scaling down the aircraft and getting it to some new proportions, still keeping all the fans and internal components the same. One of the key changes was the overall length and scaling of the jet. So it could have been a simple exercise of just shrinking our original model down. However, we decided there were certain areas of the jet that required some serious weight reduction, and one area was the tail area here. So we've reduced and sliced out 61 millimeters off the rear of the jet. Towards the front, we've also looked at a new cockpit layout. This is currently still the old cockpit, but it will. And we've also widened the jet, which had a significant impact on the way the 3D model was going to be redeveloped.
So we started again from zero, but with a lot more experience than on the first time. Maybe the first JRM version would be a good jet, but caused by these aerodynamic and weight flaws, it could never do VTOL. Parallel, a new way of lightweight construction for the wing was tested. It was built just out of ribs. We want to take a closer look on a JRM1 wing, take a completely new approach in designing it and printing it on the Bambu Lab with the new PLA Aero.
In our endeavours to reduce the weight of our JRM01B version of our VTOL jet, Renee and I looked at different ways of lightening up the structure, the internal structure, and having a review of the print infill patterns available to us through our 3D printers. And due to the popularity of the Bambu Lab printers, we wanted to investigate, come up with some wing profiles that were feasible as well as structurally sound, all printed on the Bambu Lab printer. And the following shows some of the investigations I went through to understand and capabilities of the Bambu Lab printer to print some lightweight 3D wing profiles. But on the grid pattern design, you can see the vase mode process was laying down filament very cleanly and very neatly, and allowed me to print out the lightweighted wings from our JRM01B project between Renee and myself.
As next step, we integrated an aileron to the engineered wing, which was printed in vase mode. Mark built up a very nice test stand to put the wing under bending and torsion loads.
This is the wing test jig that I've come up with based on what I had in my office. Fibre PLA bracket with a removable pin. That bracket can be flipped around through 180 degrees. That means we can test the wing in its normal flight orientation as well as up.
The bending and torsion loads that are given to the wing here on the test stands are far above than it will experience in the real flight. But nevertheless, it will show off its weak points, especially the differences between the engineered wing and the wing with the gyroid infill. So it is super interesting for us also to see where we could improve our print profiles for maximum best adhesion between the separate print layers.
Comparing the test results now of we had the gyroid infill 5% at 53 gram wing profile. It sustained a maximum load of 2 kilos and a deflection of 30 millimeters, whereas the vase perimeter printed engineered wing with a 10 millimeter grid pattern.
After some intensive weeks of CAD construction and redesigning, our JRM1B is ready to print. The spools, to keep them low moisture. It's much faster. Rough PLA from Bamboo Lab, and the first parts are finished here on the Enders 3 Pro CR10. The nose section is done here in comparison with the old one. Here we can see the 1.5mm carbon rods are running through the upper of the fuselage for reinforcing it. It's a T-motor with 2850 kV. This is the front leg mechanic. Got 180 degree servo. Here from the lower side by the main engines with a gear, and the servo for the front fan gets installed. And here it's ready working. And the main engine also start swirling. And now finally also the main struts can be installed. Just a very little bit, but they are rated for 70 amps and they are just for 45, and they also come with a little heat sink, but this is too big. I will shorten it. Both ESCs are installed, and let's go back into the fuselage. And this was over 2 kilograms when the grills are installed. Yeah, I'm really looking forward to this. We are on the final for the first flying JRM1, so we can go on. So last settings on the jet. Surprisingly, the CG fits absolutely perfect, and it was also time for the first roll and some upside down flight. What is your feeling at the moment on this plane, Martin?
Place very, very nice.
Very nice.
Oi! Oi, oi, oi!
And right after this first test flight, we decided to mount the front camera of the fuselage, which is designed as a lifting body, here visible in green by the fuselage, so even smaller wings work absolutely perfect.
Gibt's hier sofort Service?
Especially on the winglets, it looks really equal to the computer simulations. Air becomes turbulent on the outer wing and even at the trailing edge, but there was never a stall tendency or spin tendency of the JRM. As next, the droop nose has been extended, and this brings the slow flight again to an absolutely new level. It becomes more and more turbulent, but take a look on the fuselage. These strands are nearly straight. And in this picture we can see how this works so well. The strakes in front of the wing create a vortex which gains a lot of energy, and this helps to hold the vortex which is created by the wing itself over the wing, so the lift is provided just on very low airspeed. This picture shows off what would happen without the strakes in front of the wing. A delta wing itself provides a vortex which help to gain the lift on low airspeed, but with just one vortex there is just a half of energy. It's finally done! The JM1 VTOL is airborne! As more we learned about the new flight controller from SPDB, the F405, and understand to program it, as more fun we had with this project. That's why I went to the next 405 wing board. Here we got 3 stages. First, this is the PCB stage, then the flight controller itself. It's a distribution board for a lot of other things like GPS or camera. Now let's assemble this. This is the connector for these 2 stages. Just put it up. And the last stage also with the connectors. And everything is mixed on the board, that we had a chance to do a maximum on automation. So ready for maiden, JM1 VTOL, 2060 grams, perfect lightweight. Let's go. And these are the first jumps. It was getting late, as you can see. And all in all, we were happy that there was no bad surprise, but especially taking off was not that easy. But I think this was because I give not enough throttle fast enough. But after it was about half a meter into the air, it was quite stable and easy to control. Luckily, there was also not so much wind. So it was a good condition for the first hover. Yeah, and in between there was again a lot of CAD work done, especially here on the propeller holders to make them a little bit quieter. And you can see here we just need one servo to swivel the EDFs and also to retract the legs. This saves a lot of weight. There's just one small servo on the front leg, but this is the distribution board from Martech. This has an current sensor installed, but at the moment we struggle to get a signal out of it. Get a first impress how it will be look afterwards. So now iNav is again connected to set up the current sensor. Und ob da kennt ihr. Nur Code. Yes, and this is test flight day 2. We got these wonderful green landing blanket to save the jet a little bit from dirt, and it flies much better than the day before. But there was still a bit struggle with some oscillation, always on pitch. Pitch was the problem also. There was no limit for roll and pitch, so it was possible to fly really steep angles, like you can see here, assessing the behavior of the jet, and then we gave our best to tell the flight computer that it will behave a bit more handsome, especially in the PID settings. Which setting will give us the behavior we are looking for, to 100% guaranteed, like we will see in one of the next flights. Yeah, and this ground struggling you can see here, this was my fault, because on lifting up there should be done no input on the sticks, just throttle up, no AL elevator or something. This disturbs the flight computer, and the plane is wobbling around on the ground. So for lifting up, just throttle. But yeah, here you can see out of nothing, the flight computer was a bit struggling. I think we run out of its limits and we got a small crash. All in all, the whole construction managed this first hard landing. In between, David was all the time reprogramming and tuning the flight computer. So we went on testing, even it was getting dark again. I think we run all the time in a wrong direction. And yeah, we had to learn this the hard way. And then it suddenly happens. I was just banking again, and out of nowhere the jet starts struggling, shaking, and was not controllable anymore. Here we can see it in slow motion. It tries to correct itself, but even if this crash looks really bad, there was not that much damage, just the vertical steps were broken and the canopy and the front fuselage. So back in the workshop, I wanted to understand what happened, so I started hovering here and was disturbing the jet all the time to see how it reacts. I'm happy now with the PID settings. You see there was no swinging. So now we do transition from vertical start to normal flight and check the amps. Disarming. Okay. So the maximum current for vertical flight was 107 amp and for horizontal flight 65. So now transition simulation. Vertical takeoff. This was especially done to see if the sweeping servo is strong enough and also if the BEC can handle all these servos moving simultaneously. The new PID settings allows starting into the workshop. The jet hovers absolutely precise and uses very less amp. I think was hovering with about 60 amp. This allowed 4 minutes of hover time with a 5S 4200 milliamp battery. After this first success, we went back to the airfield on a very windy day. The flight behavior of the JRM-1 VTOL was very different to hovering in the workshop because of these winds. I felt that there was not this big power.
Ja, das ist ja Wind.
So needed much more throttle to keep the jet hovering, while in the workshop it was about 60%. Here it was already at nearly 80%. As the wind speed gets up, hovering became much more uncomfortable. Even as the first flight moments felt it was getting better, it was really getting worse. This roll movement was not introduced by myself. It was think it was done by a wind gust, and the flight computer has no power left on the wing fans to compensate it, and so the jet flipped over, make half a roll, I think at the end one roll, and luckily landed just on the nose, so it was not totaled. Here we can see it again, how it first starts rolling, shaking, and then flipping completely over. And we were very lucky that we didn't hit the pylon.
Das sieht ja mal lustig aus. Das ist jetzt vorne ein Kleiderhaken. Ah, das ist jetzt ein Kleiderhaken, mobiler. Schwebender Kleiderhaken. Das ist dieser Siemens Lufthaken.
Ja, das ist so ein Arschtrittding.
Das ist der Siemens Luft.
So. The missing parts on the fuselage were compensated with some lead. So it was much more power needed to keep this thing hovering here on a windy day. Now we added sweeping to pitch, that we don't have to tilt the whole plane. We sweep the main EDF just for forward flight and just in drone mode. Okay, let's test it. Stabilization movements were so big that there was a next crash.
So, ich glaube, das ist ein bisschen zu doll mit dem Pitch.
So David, now you know?
Ja, I think so.
Finally.
Yeah.
But then suddenly, out of nowhere, I was losing control again. Here in this situation I was pitching 100% forward, but even this doesn't help that the jet wants to flip backwards over. As it was getting later and the wind calms down, we decided together that we wanna do a transition attempt. To make it as safe as possible, I was climbing very slow, because we finally figured out that there was not enough power on this jet for stabilization, climbing and also controlling. The problem was, or the weak point is the two wing EDFs. They have to work on pitch and roll and also climbing, and this is too much for them. The wing or the wing position, but nevertheless we wanna use this sunny day, and we got the same result like some minutes before near the ground. As soon as the main EDF swept to horizontal, the wing fans are not strong enough to hold pitch position and the whole jet flips over. I was nearly able to fulfill the looping, but without the vector nozzles I didn't have enough pitch authority, so it smashed into the ground. Our jet crashed, and our theory why this happened: for normal hovering we have enough extra power for leveling. Yeah, I hover with about 60%, so we have 40% left for regulation of the horizontal. But when there is wind, I have to pitch forward, so I need extra power from here. So from my 60% I have maybe, let's say 80, I'm on 80, so just 20 is left for roll stabilization. And when I additionally climb, then I'm here already on, let's say, nearly 100%, so there is nothing left, just nothing, and that's why when I fly forward against the wind and climb, that's why it stumbles and get out of control. The EDF and the CG is a little bit too short, so there is not enough power from these EDF, which are already running on nearly 100%, that they are able to pitch forward. So on the next prototype we will use bigger EDFs, bigger fans, which are moved slightly backwards. So we got more power, better momentum, yeah, and then we try it again. It was obvious that major changes are necessary on this VTOL design. So the idea was to use bigger rotors. At the moment there are 75mm props installed, and they will rise to 89. This will add about 250 grams thrust on each fan, and also a fourth fan on the rear will be installed to get a much better pitch momentum. Then we went on with the front fan. Here it was necessary to widen the fuselage, that this really big fan finally fits. And also the ducting looks really good and aerodynamic. And then it was time to implement the fourth fan. But again, we were lucky that the fan fits at the end quite perfect. Also, we created some nice grill to hide it good as possible on 180 degree with a reinforced servo arm to make sure that there is no bending while open and closing this big cover door. And so the whole fuselage now is full with technique from the beginning to the end. You can see it here. At the rear is the vector servo, then comes the fan, then comes the flight controller, sweeping servos.
Achso. So cool. Gib richtig Gas. Dass er schon in der Luft steht halt vorher. Ja, perfekt. Jetzt ist besser. Und jetzt kannst du langsam runtergehen. Hier kommst. Oh. Perfekt.
You still give a good result, not bad. And here, all stabilizers. Printers had been busy overnight. Bamboo Lab is still running. There it is. V50 for VTOL. I'm so happy that we're finally printing this. Lightweight PLA parts, I really like this. There's no stringing in between these parts. In between painting. Let's have a closer look to the JRM VTOL jet. We start at the front. Here we got the front strut servo. Then we go to the front fan with the T-motor. Let's go to the VTOL sequence. I got everything on this switch. Altogether there are just 2 switches. This is to arm all the engines. Now we go to vertical mode. Everything opens up. Horizontal flight mode. Then it looks the following. First day run 45 for a little moment. Yeah, and you see everything happens quite fast. Now we can see it again with a little bit of motor running, just to see the sequence. You see just short before the covers closed, the engine shut off. Already the first indoor testing showed off that these rear EDF make a big difference in handling and all over performance. The indoor hover time raised from 4 minutes to nearly 5 minutes, which is absolutely incredible. The whole VTOL jet felt much more powerful and was very dynamic controllable. Here we are doing a transition simulation to check the maximum current and see if everything works under max load. And the max current was about 150 amps, so that's okay, and into the limits of the board, which is about 220 amps. Current on normal flight mode was about 64 amps. So last moments before first transition test of the day. Weather is wonderful. David and Henry are super optimistic, I think. Me too. Here in Germany it's autumn, so it was again super windy, but with this fourth engine it was much more easy to handle, and there was also a lot of power left for wind gust stabilization. So I was hovering with maximum 50. Has much more authority, but after solving this, everything went perfect. David is flying. Ey, super geil. even if this transition worked out nice. The front cover doesn't close because the servo was too weak. And also there were some steering issues, so it was the first hard landing on the field.
Oh ja, die ganze Zeit ist die gelaufen, wa? Hätte automatisch jetzt wieder full off. Let's go back. Ja, du musst.
Okay, Tradition. It was absolutely incredible how well this retransition works. Immediately the jet stops and was super easy to controllable and easy to land.
Gas geben, Gas, sonst geht er so schnell runter. Achso. Gas, 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 ganz viel Gas geben.
So, last programming. Nee, das.
So, jetzt ist fertig.
Ja,
Sah besser aus.
viel angenehmer.
Das ist so cool.
Flying this VTOL pattern became much more comfortable from flight to flight, also stopping in the correct moment to land best possible vertical over the green carpet was getting better and better, even with the strong winds.
Gas, 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 Gas. Ja.
While outbound transition, I still had a bit the tendency to press elevator forward. This is why the jet loses a bit of height, but this was never critical. Also, we could run these 4 engines a little bit longer so that they keep the height more, but this is everything fine adjustment and no problem at all.
Gas, 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 Gas. Hast den Rückwärtsgang eingelegt, wa?
I was also super happy with the efficiency of all the electronic components. For one complete VTOL pattern with vertical start, flying, some pattern and vertical landing, the engine consumption was about 1200 to 1400 milliamps. So just a third of the full capacity. So theoretically you can fly 3 complete VTOL pattern with 1 battery.
Ja, naja, die werden ja hier wie die Handykameras, ne? Die werden ja immer kleiner und trotzdem gut. So, David managed to land also on the carpet. Perfect. Just perfect. Very good.
Komme ich ja rum und dann halte ich hier ein. As next we did a mid-air stop, like a in-air touch and go, and this works also super nice.
Ja. Das ist so cool.
1, 2 gerade mal raus.
And after some acrobatics, it was time for vertical landing. So this was the first time I was flying 2 complete VTOL pattern with 4 transitions in one flight.
Also falsch rum den Jorgen bewegt oder was?
Ja. 3131 from 4200. So still 1/3 left power. Very good. Very good. Very good.
Das ist einfach so cool.
Interestingly, there was never an issue of running out of power because of this super efficiency with these 4 drone motors. There was always enough capacity left, also even with doing 2 transitions in one flight and also hovering afterwards. This was one of the biggest safety features, I think, of the JM1 VTOL. You won't run out of power.
Mal hier.
Nicht fallen lassen.
Super geil. Super geil. Okay, dann ab zum Tisch.
This was an absolutely incredible test flight day. Big thanks to David and Henry for this superb teamwork. We managed so much difficulties and at the end everything works out absolutely perfect and this was so much fun. This jet, JM VTOL jet is absolutely enormous. I really can't describe it, how much fun it is. I think I will fly this so much several times, print the next one and just have fun with it. And also you can download this from now from our website aerojtp.com. There you also can find the JRM CTOL version here in gray-green in the picture and a lot of more super interesting jets. And we will we will also have a lot of new constructions to come into the future, but for the moment we really celebrate the JRM VTOL. This was a work of now I think 2 years, almost exactly 2 years. We work on this, did a lot of CAD work and a lot of design changes and a lot of things till it really keeps working like a Switzer clock, how to say. And I think it was absolutely worth it. It is an enormous, wonderful airplane and now we can enjoy it. So now get your JRM VTOL soon and we see us in the next video. Bye bye.